presentation about templates, and it was fortuitous that this kind of dovetails into Vincent's presentation earlier about working, creating your mount design, getting the information you need in advance of an exhibition, and then be able to prefabricate the parts that you need before the objects arrive. And again, it was great to see a good example of that and where it really works. So this is just some brief ideas about different techniques that my colleagues and I come up with, just when we have these opportunities to get out, how we can successfully get the information that we need, so that when we get back to our shop, so we can make mounts that fit when the objects arrive. And so we're cutting down the time that's necessary to fit and have the objects ready for installation. I'm sure everyone faces the same challenges. You know, the objects arrive, you have a very short amount of time to work with it before it's installed, and especially with large exhibits with couriers, those time constraints become even more of an issue. So anyway, this is just some basic ideas, maybe to get some thoughts going about different methods that could be helpful. So the challenge, as I just said, is not having the artwork in front of you. I mean, ideally, it's on our workbench and with us the whole time that we're working with the mount and getting things to fit the way we want. But you know, that's not always the case. And so, faced with those situations, you know, these are some ideas that you could do to get the information. So, again, working with time constraints, couriers, tight installation schedules. Ideally, you have a chance to get out in front of the exhibition and the planning, and you're not at the tail end and trying to make everything work. And in these situations, you know, there's a lot you can do. Having a plan, I think, is essential. And you know, anything you can do to be a part of the design process early on with the curators, the designers, and working with them and collaborating to discuss what's possible, and having that information on hand before you see the object is helpful and will really direct your mount design. So I'm going to start with paper templates. It's sort of the bread and butter of a lot of the work that we do with templates. And I'm going to start off with some just real basic stuff, so I'm sorry if it's a little rudimentary, but it'd be worth covering. And before I go too far into templates, I want to talk about you know, the relationship of the object to the display surface, and that's something to keep in mind when you're making a template, and it'll make your life a whole lot easier later on when you're fitting the mount to the object. As you can see, the red line obviously being the display surface, and the yellow line being the profile of the object. Getting that established in your template, especially with things like contour mounts, where you're traveling the distance up from the display surface, any inaccuracies with that horizontal line will cause a lot of problems. So if you can get that in early on and keep that in part of your mindset when you're creating your template, will be really helpful. There's a lot of different methods for acquiring information, real basic stuff. Profile, contour gauges are some of the most common, but they tend to be limiting. The measuring elements on most of them are pretty short, or they're metal, which is not ideal with artwork. And as Vincent sort of showed in his presentation, you can make one with longer elements. But my experience with them is they tend to be tough sometimes to keep that relationship with the ground, your display surface in your template. But they do serve a purpose and are definitely a worthwhile tool for acquiring the shape of an object. Flexible curves as well, but they're limited in what they can, the detail of a shape that, as you can see an example, they just don't bend very far. And a lot of them don't hold their shape very well, but they are a useful tool for getting general shapes quickly. There's also another device which experimented a little bit with called a log scribe, and I've had mixed results with it. It takes a lot of practice, and as you can see in the example, it's you need a really steady hand. It's not a necessarily intuitive kind of tool to work with, but it does seem to have some applications where it could be useful. Probably the easiest solution is just cutting out paper shapes and starting to piece them together and work your way along the profile. It's super easy, and you can, if you spend a little bit of time with it, you can really get a lot of detail with it. You can then transfer that construction to a clean sheet of paper or a cardstock, or just continue to tape those pieces down so that nothing moves. This is a contraption that my colleagues and I came up with a few years ago to sort of expedite the process of taking profile contours. It basically has a horizontal element that travels up and down, and vertical element travels up and down, horizontal element that moves in and out. And as you can see in the example, there's a stylus that travels along the edge of the object, and a pencil end on the other that transfers it to the cardstock. And this device has worked out pretty well for taking very simple profile shapes quickly. They usually need a little bit of tweaking, but you can really get through a number of objects quickly with this device. After you have your shape transferred to your cardstock, you want to cut it out very carefully. The more accurate you are with your template, obviously, the better fitting your mount will be. You'll have an accurate pattern to work from. And both sides of the template are useful. The one side, the negative shape, can be used as a pattern for forming your stock, and then the positive shape can also be used to represent your object. And I think Vincent showed that a bit with his presentation as well. So both sides of that template are useful. And one thing to consider too, when you're working with your template, is to make to account for any sort of barrier or padding you're going to have in your template. It's not so crucial with templates to have more of a vertical component to it, but any horizontal parts, things that have undercuts, you have to account for that amount of space in your template. So as you can see in the example, drawing it out and then cutting away that approximate amount of padding will have a mount later on that will be more accurate in accommodating that padded barrier. And then also having a board to work from that you can use as a registration point to keep your template and your mount components as you're fabricating. It gives you a good registration. It simulates your display surface, and it really helps keeping things staying in alignment during the fabrication process. Paper templates can definitely be used for more complex shapes. And one thing to consider when you're dealing with complex shapes is taking a lot of images. Images really help later on once you have your templates and you're away from the object, and taking a lot of notes as well. Writing down as much information as you can while you have the object in front of you, along with these images, and making registration notations on the templates of where the mount components intersect. Anything you can do to have that information documented, so later on you're not trying to recall what parts went where. It just expedites the whole process during fabrication. I wanted to go a little bit further with paper templates. This was something that I experimented with recently. Instead of using the cardstock as a template for the object, I used it to create a maquette of the mount that I was planning to fabricate. Having a plan, working with the exhibit designer and the curator, they wanted to see this object displayed on the wall on a structural shelf, tilted at a 20-degree angle. This object was part of a large traveling Byzantine exhibition that was at the National Gallery prior to its display here at the Getty. I had a chance to see the object during the installation at the National Gallery. I want to thank Drew and Linda for giving us that opportunity to sort of encroach on their installation and get some information. But it proved invaluable. This piece had some great opportunities to support and capture the object. You can see these cavities, both at the top and the bottom. And it allowed me to mock up the structural mount that I was planning to make for this. And it's up at the top, a retaining clip. Then once I was back at the Getty, I was able to then translate that paper maquette into a steel mount. There's the top clip. Then the object arrived just prior to its installation, and I had the prefabricated part ready. The maquettes worked very well. I was pleasantly surprised. I hadn't used this method before, but I definitely will consider using it again. There was no modification needed, and it was good because it was a complicated mount and required, even at this point, casting and resin interface and paint and all, which was very time consuming. There's the top clip. And then the piece on display, and it all worked out quite well. But again, having that opportunity to see the object in advance and having a plan, I can't stress enough how much that made a difference in a very large traveling exhibit with a lot of with the time constraints that really would have been impossible to create a mount of this complexity just with the object having arrived in a short amount of time before it went on display. Another technique, moving away from paper templates, is casting, and these are some examples from my colleagues at the Getty Museum at the Decorative Arts Conservation. This is a method of where they used a silicone casting agent that was reinforced with perforated aluminum sheeting to create a mold of the object where the clip was going to contact. They used that method then to create a plaster cast positive, and then used those positive castings to fit pre-made clips. All of that then allowed them to install a very complicated exhibit efficiently, having a lot of information of the piece. Clips were already sized and fitted for the objects before they arrived. Another method that they had been using was it's actually casting the clips out of bronze, and so they using both a hard wax for the body of the clip and then a softer wax for the detail of the object. They were able then to take those wax molds and have bronze clips cast for this particular exhibit. I've experimented a little bit with casting as well, but in a different fashion. I was faced with an object where a paper template really wasn't going to get the information that I needed, and I had available a quick setting epoxy putty, and it allowed me to basically create another maquette of the mount that I would fabricate later. The resin gave me a good impression of the object where the mount was going to contact. It also gave me the size, the diameter, and approximate depth of the hole that's on the bottom of the piece. And then it also gave me, though you can't see it in the one image, it also showed me the approximate location of the post that I would add later. With that casting, I cleaned it up. I made the structural component out of steel and actually was able to use a part of the casting as an interface that I later adhered to the steel part. And you can see here where it was finished, and it fit quite well with the object. But it gave me an opportunity to get a lot of information quickly and accurately. Another technique that we're starting to experiment with is scanning, and there's a lot of possibilities with this. The technology is improving all the time, and the affordability is making it more accessible and a possible tool in the future. In this example, we had a company demonstrate one of their products to us, and we had them scan this little vase, and on one side I printed out a paper profile of the scan, and I cut it out and fitted the cutout to the real object, and as you can see, it fit remarkably well. I mean, the shape is pretty simple, but it's encouraging, and I think that there's more opportunity to experiment with this. And this is pretty rudimentary, but then it opens up the possibilities of 3D printing as maybe an area where mount components can be fabricated based on a scan, positive replications of various object surfaces could be made, but between the affordability and just the increasing improvement in the technology, it definitely has a lot of possibilities. So, in conclusion, there's a lot of different methods out there. Most of them are very simple. Some can be more involved. But I think the main thing that I wanted to stress with this is besides different techniques, is the importance of us as mount makers inserting ourselves early on in the process to have these opportunities to get out, get the information we need before we're faced with trying to figure out a compromised solution, which isn't a great place to be. I mean, you have valuable cultural assets that you're trying to present in a in a safe manner. And anything you can do to be more in the planning process, I think, is where we want to be. It's an important place.